Physical science practice exam. First page. First part is just a matching. There's 4 things, and you have to figure out which part of the scientific method is. If you test something, you must be performing an experiment. That's letter D. But if you're reading reports before analyzing anything, you're just gathering info. That's letter B. You chart the temperature from the data collected. So we must be past the perform the experiments, and we must be recording and analyzing data. That's letter E. And if the driver follows the traffic rules, the number of accidents will decrease. Is that true? Sounds like a hypothesis to me. That person formed a hypothesis. The next ones are dimensional analysis. We are doing some converting, and they give us some facts. The way I like to convert is if I start with whatever they give me, 55 millimeters, I'm going to put that over 1 just so I can tell it's at the top of a fraction. I'm going to set this up in such a way, there's a couple of facts there. I'm trying to get from millimeters into meters. I'm trying to set this up in such a way that millimeters cross off and meters stay. Problem is, I see millimeters and centimeters, but I don't see how many millimeters are in a meter, so I'm going to have to do this in 2 steps. This says that 10 millimeters is 1 centimeter. That'll allow me to cross off millimeters. It does not get me where I'm going, though. Where I'm trying to get to is meters. I want meters on top, and I need centimeters to cross off. What's the fact? 100 centimeters equals 1 meter. So I set this up in such a way that every time cross, 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 when I'm all done, 55 divided by 10 divided by 100, 55 divided by 10 divided by 100 equals 0.055. 0.055. What's my unit? Whatever didn't cross off or whatever they asked me, meters. 12.5 kilograms into grams. Start with whatever they gave me, 12.5 kilograms. I like it over 1 so I can tell it's at the top. Kilograms has to cross off. Grams has, whoops. Kilograms has to cross off. Grams is going to stay. I want it, so here's my numbers. 1,000 goes with grams, so put that on top. 1 goes next to kilogram, put that on the bottom. 12.5 times 1,000 is 12,500 grams. 12 cc, which is a cubic centimeter. They give me all kinds of information here. Ultimately, if I'm going 12 cc, I have to change that into liters. Well, they don't tell me how many cc's are in a liter, but a cc is simply a milliliter. They're the same thing. And so, and there's 1,000 milliliters in a liter, so therefore there's 1,000 cc's in 1 liter. 12 divided by 1,000 equals, I'm just going to move the decimal place over 1, 2, 3 places, put a 0, 0.012 liters. What is the basic unit of mass? Well, that would be the kilogram or kilogram. What is the basic unit of volume? The word liter should come to mind. Basic unit of length. Remember, we're talking metric system. Meter. And finally, what's the basic unit of temperature? Degrees Celsius. Degrees Celsius. If you would put gram, I could understand that. Kilogram is technically correct, but if you drop that gram. Next one, density. Density had a round little buddy. Density, MV. I want to know the mass. Cover up mass, and it's going to say density times volume. 3.4 grams per cc times 2 cc's equals, let's see, cc and cc, 6.8 grams using a round little buddy. Page 2. Describe the transfer of heat by convection, conduction, and should say radiation. Provide an example of each. Convection. Heat travels by currents. Conduction. Heat travels by direct contact. And radiation heat travels across open space or empty space. It does not require any substance like air or water or metal to conduct it. Some examples: heat by currents, hot air rising. That's convection. Conduction is like if you put a, like touch a warm door, or maybe if you hold metal in fire, the end of the metal gets hot. And finally, heat travels across empty space. Sun's energy reaches Earth. It would also be if you were like standing by a fire and you could feel it even though there was no wind going your way. In the box below, please describe each state of matter in terms of motion, and then diagram the arrangement of the atoms and the molecules. In a solid, if I was to look at the arrangement, they would be nice and neatly arranged. The particles would, in a nice, neat, organized manner, but they do vibrate back and forth. We look at those as not moving. In a liquid, if I draw something, they're also touching, but they're not as neat. They can slosh around, and they're sort of a little more random, but they are close enough to touch. But I'm trying to make it so it doesn't look as organized and neat, and it has to stay in that container. The motion of the atoms. The particles move, but stay together. Stay near each other. And finally, what's going on with a gas? If I was to draw a picture of like a balloon of a gas, all the particles would be moving randomly about inside there, bouncing off each other. Particles bounce off each other. Next one, describe the physical change of an object as ice melts on a molecular level. How would I describe that? The solid particles break apart as heat is added. And turn into a liquid. That's the end of page 2.